Good morning. My name's Ian Jolliffe. I'm from Wind River, and really happy to be here representing a Canadian-based set of developers working on OpenStack. We're actually from Ottawa, Ontario, Canada, and it's super nice to be able to talk to a bunch of people about what we're doing in the security space and representing our security team here at the summit. We've been doing some work on TPM over the past year or so. Trusted platform modules, but also taking those to a virtualized context. And so thought I'd share a bit today about the backstory there, some of the activities that we've been doing, leveraging a number of open source projects to make this work, as well as some blueprints we're thinking of proposing as well. So first, a bit about Wind River. We actually have billions of devices running our software on planet Earth, but also on Mars. So our software is also running on the Mars rover. So that's kind of a neat story to be able to tell. But we also have a set of cloud products called Titanium Cloud. And that's the project that I work on and the technology I'll be talking about today. We really view the promise of cloud technologies in critical infrastructure areas as being a huge new area. And a lot of the work that we're hearing about edge computing today is really exciting as well. And we've got other talks going on about the Starling X project that we're contributing to, which I encourage you to attend as well. But really our focus is on enabling networking solutions at the core, but also at the edge, increasingly at the edge, I would say. We've got demonstrated track record in telecom, but also with industrial applications, and as things move to the edge, the need for security increases very, very significantly. And really we're seeing an inflection point right now where 5G is really causing a networking evolution, but it really enables an IoT revolution, and security is a very key part of that. Obviously we hear a lot about Defenseindepth and how critical that is. We have a number of solutions that address Defenseindepth, so obviously authentication for the guests, virtual TPM, which I'll talk about in more detail, but also making sure the attack surfaces are small as possible. So let's find out a bit more about what TPM is or is not. So TPM is a trusted platform module. It's a device that exists on a server. It's a small rectangular chip that you can buy or have specified it to be included in your server. And it's a place to store the critical secrets like certificates, keys, passwords, things like that. It does have a limited memory space, so you have to be selective on what you actually store in that device. It also has a random number generator, which is much better than a software-based random number generator. So it can enable some very interesting use cases from that perspective. TPM, however, is not for DRM, for digital rights management, licensing, or cryptographic acceleration, or dedicated hardware security modules, which are typically a full card solution. So virtual TPM is of taking that hardware-based TPM and device and making something similar available to virtual machines. But it's not really yet another security overhead. We want to keep this lightweight. We want to be able to still live migrate VMs from one host to another and still be able to manage it. So that's what we tried to come up with in the solution that we've prepared. So the virtual TPM allows you to store all the secrets for the guest, allows you to secure boot that instance. It also is tied into libvirt, so it is fully virtualized. It supports live migration as well as cold migration, and also allows you to upgrade your hosts underneath it and still have your VTPM module work. Again, talked a little bit about the random number generation in the hardware-based TPM, but we've also got that capability in virtual TPM space as well. It leverages the RD-RAND instructions in the registers to actually compute those. And it allows you to improve the /dev/random in the guest as well. Also, people are using VTPM for trusted boot, so basically storing the BIOS and firmware arguments as well. And also, people are using VTPM for disk encryption capabilities. So how does this all come together? So we leveraged a number of different open source projects. There's actually a couple of instances out there. I encourage you to look at the various solutions out there from Intel and IBM. They're both very good and have good ecosystems around them as well. But one of the things from an OpenStack context is to be able to leverage a virtual TPM in the instance, we probably need a flavor extra spec. And so we'll be working with the community here later this week to be able to add in support for a flavor extra spec and get input on that blueprint that we're proposing. So at the next level of detail, we basically have a software-based TPM2 device for that guest. So basically the same capabilities that you'd see on the host would be available to a VM. So if, for example, you had a VM that was an application that used to run on bare metal hardware, you can now leverage, and it was using physical TPM, now you can leverage that same service in a virtualized context. So there are some libraries you need to have in the guest as well to make this work. And really what we put in the guest is a place where you can see where these keys are stored. And so I've got a short demo that I'll show you where we actually create this region in memory, show the keys, live migrate the instance from one host to another, and show that the keys are preserved and migrated across. So that's coming up here. Let's go with the demo. So we're going to start by launching the instance with the VTPM device with the value set to true. It's going to get launched. And then we'll see it running on a host. And so this instance has been launched using with a virtual TPM device. And we'll see it spawning here. And it'll boot onto a physical device on one of the hosts. And it's on compute 2. And down below here, we're showing the TPM device. And so it's you'll see it's a 06A. And now we're going to actually live migrate this running VM from one host to another and still preserve those security secrets on the new host. So it's going to migrate over to compute 0. We'll log in and we'll see that same file has been preserved and now available for keeping all those secrets secure from one place to another. So the demo is a bit longer than the time I have available, so I'm going to just wrap up here because I think I've only got a few minutes left. So as I said, Trusted Platform Modules is really a hardware-based physical device. What we've done is turned it into a virtualized instance that can be tied to a VM. It's a really great step in showing end-to-end trust for your virtual machines in the cloud. Obviously, you want to secure your hosts as much as possible, as well as your physical security, so you've got Defenseindepth. And thank you very much for your attention. Thanks for a quick 10 minutes. Thanks.